Hello, I will talk about special relativity and the twin paradox. Special relativity is an explanation of how speed affects mass, time, and space. As an object approaches the speed of light, the mass of the object becomes infinite, and so does the energy required to move it. This means that it is impossible for any matter to go faster the speed of light, or even reach the speed of light. Now I will talk about the twin paradox. The first twin flies into space at a very high speed and returns to Earth while the second remains on Earth. According to the theory of special relativity, movement at high speed slows down the flow of time. So the brother who went on a journey in space if he traveled at the speed of 80% of the speed of light, he will return to Earth 10 years younger than his brother who stayed on Earth. Now I will describe the paradox in detail. One twin remains on Earth while his brother moves away in a spaceship at a very high speed, close to the speed of light. At some point, the brother turns around and returns to Earth. According to the theory of relativity, the journey in the spaceship will take less time than on Earth, which will lead to the brother in spaceship returning younger than the brother left on Earth. For example, suppose the journey is to the star Epsilon in Eridanus, which is about 10 light years away from the solar system. And the speed of the spacecraft is 80% of the speed of light, that is to say 240,000 kilometers per second. According to the twin left on Earth, the round trip time as measured on Earth is T naught equals to 2 times L naught divided by V. So it is the time is the way divided by the speed, yes? So the total way of the brother in the spaceship is from Earth to the star Epsilon and back from the star Epsilon to Earth. So it travels back and forth. So the total distance will be 2 times L naught, that is 2 times 10 light years, because the distance between the Earth and the star Epsilon is 10 light years, and because of the fact that he does the travel back and forth, we multiply by 10 light years, and we divide by the speed of the spaceship, that is 80% of the speed of light, 80% of 300,000 kilometers per second is 240,000 kilometers per second. And the total weight divided by the speed of the spaceship is the total time that will take to the brother in the spaceship to do the journey. The total time is 25 years. According to the Lorentz transformation, the time measured by the twin in the spacecraft is T spacecraft equals to T naught times root of 1 minus V squared divided by C squared. So the total time will be the time that is measured on Earth by the twin brother, that is 25 years, times the root of 1 minus V squared divided by C squared. So it is 25 times root of 1 minus 0.8, that is V divided by C, 0.8 squared, and the final result is 15 years. So the total time that will take to the brother in the spaceship to do the journey is 15 years, because of the fact of time dilation. Because of the fact that the twin brother that is in the spaceship travels at a very high speed, then the rate of time flow in the spaceship will be slower than the time flow on Earth. So the time flow in the spaceship is slower than the time flow on Earth. And this phenomenon is called time dilation. So, because of time dilation, the total journey of the brother in the spaceship will be 15 years. Yes. But according to the twin in the spacecraft, he is at rest, while the Earth on which his twin brother is, and the star Epsilon in Eridanus are moving across it at a speed of 80% of the speed of light. As a result, the distance between them shrinks according to the Lorentz transformation. So the distance it must travel is L spacecraft equals to L naught times root of 1 minus V squared divided by C squared. So because of the fact that the twin brother travels in the spaceship at very high speed. From his point of view is in rest, and the planet, the star Eridanus, the star Epsilon, moves towards him in a very high speed, that is 80% of the speed of light, and that is the reason that there will be a time contraction. When someone or something travels at a very high speed towards you, there will be a contraction of distance between you and the object that travels at very high speed. This is according to the special relativity. So because of the fact that from the point of view of the brother that in the spaceship, he is at rest, and the star Eridanus is moving towards him in very high speed. So that is the reason that there will be time, there will be distance contraction, and the distance between the spaceship to the star Epsilon will be only 6 light years because of time contraction, because of the distance contraction that occurs according to special relativity, because of the fact that the star Epsilon moves towards the spaceship at very high speed. That is from the point of view of the brother that is in the spaceship. So, and that is why we got the result of 6 light years. So the distance between the spaceship or the Earth to the star Epsilon contracted from 10 light years to 6 light years. So it contracted in 40%. So now we can calculate the time that will take to the brother that in the spaceship to do all the journey back and forth, and the total time will be T spacecraft equals to 2 times L spacecraft divided by V. So I have already explained that the distance between Earth or the spaceship to the star Epsilon is only 6 light years because of the fact that the star Eridanus is moving towards the spaceship in very high speed in the point of view of the brother that is in the spaceship, and that is the reason that there will be a contraction of distance between the spaceship and the star Epsilon. From 10 light years, the distance will contract to only 6 light years. So the total distance that the brother in the spaceship travels is back and forth is 6 light years times 2. It travels back and forth. So the total distance is 12 light years, and it travels at the speed of 80% of the speed of light. So 12 divided by 0.8 is 15 years. So the total time that will take to the brother in the spaceship to do all the journey is only 15 years. So in Earth we measured the total time on Earth is 25 years, and in the spaceship the total time will be 15 years because of the contraction of distance. Okay? So therefore the two twins effectively agree that the twin in the spaceship will be younger when they meet again, in terms of the twin that remains on Earth due to the effect of time lengthening or time dilation, as I have already explained. And in terms of his traveling twin due to the contraction of distance, yes? The distance between the Earth or the spaceship to the star epsilon contracted from 10 light years to 6 light years. So the total distance that the brother will travel will be 6 times 2, because it is back and forth. The total distance is 12 light years, and it travels at the 80% of the speed of light, and so the total time that it will take is the total way divided by speed. So it's 12 light years divided by 0.8, that is 240,000 kilometers per second, and we get 15 years. Okay? Okay, thank you very much.